ओके, आज हम इलेक्ट्रिसिटी से स्टार्ट करेंगे क्वेश्चंस। और फर्स्ट हम सिर्फ इलेक्ट्रिसिटी, इलेक्ट्रिक फील्ड, इलेक्ट्रोस्टैटिक्स, बेसिक मैग्नेटिज्म, इनसे रिलेटेड क्वेश्चन सॉल्व करेंगे। इलेक्ट्रोमैग्नेटिज्म फिर हम एक क्लास में इसमें कंप्लीट सिर्फ इलेक्ट्रोमैग्नेटिज्म के ही क्वेश्चंस करेंगे। ठीक है। तो आज हम बेसिक इलेक्ट्रिसिटी और करंट इलेक्ट्रिसिटी, इलेक्ट्रिकल क्वांटिटीज, इलेक्ट्रोस्टैटिक्स, बेसिक मैग्नेटिक फील्ड्स, इन सबसे रिलेटेड क्वेश्चंस आज आज डिस्कस कर लेंगे। फिर उसके बाद जो नेक्स्ट टाइम स्टार्ट करेंगे उसमें कंप्लीट हम इलेक्ट्रोमैग्नेटिक इंडक्शन और इलेक्ट्रोमैग्नेटिज्म वाला पार्ट वो कंप्लीट एक ही गो में डिस्कस करेंगे। ठीक है, तो सेम पैटर्न 23 से स्टार्ट करेंगे। तो ये फर्स्ट क्वेश्चन, फिगर 7.1 shows the electric field pattern around a point X. On figure 7.1, draw an arrow to indicate the direction of the force on a negative point charge placed at point Y. तो विद द हेल्प ऑफ एरो हमने डायरेक्शन ऑफ फोर्स को शो करना है ऑन अ नेगेटिव पॉइंट चार्ज प्लेस्ड एट पॉइंट वाई। तो यहाँ पर नेगेटिव चार्ज एक प्लेस किया है और आपने ये बताना है दैट व्हाट विल बी द डायरेक्शन ऑफ द फोर्स ऑन दिस नेगेटिव चार्ज। अब आपको खुद आइडेंटिफाई करना होगा कि ये सारी फील्ड लाइंस आउटवर्ड है, यानी जो सेंटर में चार्ज है वो पॉजिटिव है, क्योंकि पॉजिटिव की फील्ड लाइंस जो है वो आउटवर्ड होती है। So at point X we placed a positive charge and at point Y we have negative charge, क्योंकि वो क्वेश्चन में मेंशन है। So definitely both will attract each other. So this negative charge will attract towards the positive charge. And second, what is at point X? State what is at point X to produce the field pattern shown in figure 7.1. तो वो हम पहले डिस्कस कर चुके हैं कि सेंटर में जो है वो पॉजिटिव चार्ज होगा बिकॉज ऑल फील्ड लाइंस आर रेडियली आउटवर्ड। पॉजिटिव पॉइंट चार्ज field lines are radially outward. Part B, a piece of plastic is charged positively by friction. State what charges transfers occur during this process. ठीक है, एक पीस ऑफ प्लास्टिक है जो पॉजिटिवली चार्ज हो गया और हमने मेंशन करना है व्हाट चार्जेस ट्रांसफर्स अकर ड्यूरिंग दिस प्रोसेस। तो ये भी आपको बताया कि सिर्फ इलेक्ट्रॉन्स फ्लो कर सकते हैं। ठीक है, तो इलेक्ट्रॉन्स मूव अवे फ्रॉम द प्लास्टिक या आउट ऑफ द प्लास्टिक बिकॉज प्लास्टिक इज पॉजिटिवली चार्ज। So it means plastic lose electrons and second body gains electrons. So basically electrons move करेंगे यहाँ पर। आप इलेक्ट्रॉन्स लिख सकते हो, नेगेटिव चार्ज भी लिख सकते हो। नेगेटिव चार्ज मूव आउट ऑफ द प्लास्टिक और पार्ट सी, एक्सप्लेन हाउ द स्ट्रक्चर ऑफ एन इलेक्ट्रिकल कंडक्टर differs from the structure of an electrical insulator. आपके पास यहाँ पर इलेक्ट्रिकल कंडक्टर इलेक्ट्रिकल इंसुलेटर में क्लियर डिफरेंस हमें पता है कि इलेक्ट्रिकल कंडक्टर में इलेक्ट्रॉन्स फ्री टू मूव नहीं होते। इलेक्ट्रिकल इलेक्ट्रिकल कंडक्टर में इलेक्ट्रॉन्स फ्री टू मूव होते हैं, इंसुलेटर्स में फ्री टू मूव नहीं होते। ठीक है, तो ये हमारे पास बस इसमें एक डिफरेंस होगा। इलेक्ट्रॉन्स इन कंडक्टर whereas insulators do not have free electrons। ये तो फर्स्ट क्वेश्चन काफी बेसिक था। क्वेश्चन नंबर 6, on figure 6.1 sketch current voltage graph of a filament lamp and explain its shape। So basically for filament lamp में रेजिस्टेंस और टेम्परेचर दो चीजों की बात करते हैं। ठीक है, कि इसमें दोनों क्वांटिटीज रेजिस्टेंस और टेम्परेचर दोनों डायरेक्टली प्रोपोर्शनल होते हैं, और जब दोनों डायरेक्टली प्रोपोर्शनल हैं तो रेजिस्टेंस इंक्रीज होने की वजह से इलेक्ट्रिक करंट डिक्रीजेस और वोल्टेज और पोटेंशियल डिफरेंस आल्सो इंक्रीजेस। क्योंकि रेजिस्टेंस हाई होगा, पोटेंशियल डिफरेंस भी इंक्रीज करेगा। सो लेट्स सपोज अगर हम वाई एक्सिस पर पोटेंशियल डिफरेंस रखते हैं, एक्स पर पोटेंशियल डिफरेंस, वाई एक्सिस पर करंट, तो ग्राफ जो है वो बेंड होगा टुवर्ड्स वोल्टेज एक्सिस। ये हमने फिलामेंट की उसमें पूरी डिटेल में भी मेंशन किया था। इनिशियली तो दोनों डायरेक्टली चलेंगे कुछ टाइम, उसके बाद फिर ग्राफ बेंड होना शुरू हो जाएगा टुवर्ड्स वोल्टेज एक्सिस। फॉर एक्सप्लेनेशन, as temperature increases, resistance also increases। तो करंट डिक्रीज्ड, या हम ये भी लिख सकते हैं कि वोल्टेज भी इंक्रीज हो जाएगा। इन फिगर 6.2 इट शोज एन इलेक्ट्रिक सर्किट। उसमें डायोड्स हैं और बैटरी है, और रेजिस्टर्स, वोल्ट मीटर, एम मीटर। सारी चीजें कनेक्टेड हैं। और फर्स्ट ऑफ ऑल यू हैव टू कैलकुलेट द रीडिंग ऑन द वोल्ट मीटर। सो रीडिंग ऑन दी वोल्ट मीटर आपने कैलकुलेट करना है। और डायग्राम में अगर आप ऑब्जर्व करो तो एक प्रॉब्लम ये है कि जो दोनों बैटरीज कनेक्टेड हैं, 12 वोल्ट और 3 वोल्ट, दोनों के टर्मिनल्स एक दूसरे को सपोर्ट नहीं कर रहे हैं। ठीक है, 12 वोल्ट्स जो सोर्स है वो करंट फ्लो कर रहा है फ्रॉम लेफ्ट हैंड साइड, और 3 वोल्ट का जो सोर्स है वो करंट फ्लो कर रहा है फ्रॉम राइट हैंड साइड। तो ये दोनों एक दूसरे के ऑपोजिट वर्क कर रहे हैं। ठीक है। और जब आप पोटेंशियल डिफरेंस की बात करोगे वोल्ट मीटर में, तो वोल्ट मीटर आपके पास ऐसी जगह पर कनेक्ट है कि वो डायरेक्टली इनके साथ पैरेलल कनेक्शन में आप उसकी वैल्यू फाइंड आउट कर सकते हो, क्योंकि वो एक करंट की वैल्यू यहाँ से फ्लो करते हुए आएगी फ्रॉम लेफ्ट हैंड साइड, और दूसरा दूसरे एंड से। तो दोनों के ऑपोजिट रिस्पॉन्स की वजह से जो रीडिंग होगी वोल्ट मीटर में, 9 - 3 वोल्ट, सॉरी 12 - 3, और 12 - 3 आपको जो है वो फाइनल रिजल्ट देगा वोल्ट मीटर में
9।
9 वोल्ट। ठीक है। तो इसमें भी और कुछ इतना डिटेल नहीं करना हमने, क्योंकि वो आपको बैटरी से पता चल रहा है दोनों ऑपोजिट आएंगे।
Sir, I have a question.
हम्म।
Do we have to say 9.0?
बेसिकली इट इज नॉट कंपल्सरी टू राइट 9.0। बेसिकली जब आपके पास क्वेश्चन में एक पैटर्न हो वैल्यूज का, तो आप उसको कॉपी कर लो तो और अच्छा हो जाएगा, अदरवाइज नो इशू।
All right.
क्योंकि आप 9 को कुछ भी करके दो सिग्निफिकेंट फिगर्स तक लेकर नहीं जा पाओगे, तो इस वजह से वो 9.0 मेंशन कर देते हैं, क्योंकि राउंड ऑफ वैल्यूज गिवन है क्वेश्चन में। नेक्स्ट, कैलकुलेट द करंट इन द 4.2 ओम रेजिस्टर। अब 4.2 ओम रेजिस्टर में करंट फाइंड आउट करना है। सो 4.2 ओम यहाँ पे कनेक्टेड है। सो इफ वी कंसिडर अ 12 वोल्ट बैटरी, सो 12 वोल्ट बैटरी से करंट फ्लो करेगा डायोड के थ्रू। अच्छा, डायोड जो है वो फॉरवर्ड बाइस्ड है, जो 4.2 के साथ कनेक्टेड है। ठीक है। तो ये करंट को कैरी ऑन करा देगा 4.2 ओम रेजिस्टर तक। एक तो ये बात हो गई, और दूसरे एंड पर अगर आप देखो, तो दूसरे एंड पर डायोड जो है वो रिवर्स कनेक्टेड है, तो वो रिवर्स बाइस कर रहा है, तो यानी 12 वोल्ट्स जो है वो 2.1 को रिसीव नहीं हो पाएंगे, क्योंकि वो रिवर्स बाइस में कनेक्टेड है। ठीक है, एक तो ये चीज भी हम इसमें नोटिस करेंगे। और अब आपने जो है वो इसमें करंट कैलकुलेट करना है। ठीक है, करंट के लिए बेसिकली वी हैव टू यूज दैट ओम्स लॉ, V इज इक्वल्स टू IR। सो अब हमने क्या करना होगा यहाँ पर, अगेन आपको पता है कि इस 4.2 ओम्स को दोनों एंड से करंट मिल रहा है। ठीक है, मतलब दोनों एंड से पोटेंशियल डिफरेंस की वैल्यू और जो करंट वैल्यू है वो यहाँ तक इजीली रीच कर पा रही है। तो यहाँ पर भी हम वोल्टेज क्या करेंगे, 12 - 3 वाला यूज करेंगे, यानी 9 वोल्ट्स। I इज इक्वल्स टू V/R। सो वोल्टेज 9 कंसिडर करेंगे, रेजिस्टेंस 4.2। ठीक है, डायग्राम से कंफर्म कर लिया कि दोनों एंड से जो करंट होगा वो 4.2 तक इजीली कैरी ऑन हो रहा है सर्किट की डायग्राम के अकॉर्डिंग। सो 12 - 3 9 वोल्ट्स। अब जैसे सेकंड डायोड है उसमें रिवर्स हो रहा है, तो वहां के लिए फिर हम डिफरेंट यूज करेंगे कॉन्सेप्ट। तो 9 डिवाइडेड बाय 4.2,
2.14.
2.14 और 2.1 एम्पियर। ओके, नेक्स्ट पार्ट, current in the second resistor, that is 2.1 ohm resistor. So what will be the current in the second resistor, 2.1 ohms? अब क्योंकि 12 वोल्ट्स जो है वो तो उससे उसने रिवर्स करा दिया। ठीक है, 12 वोल्ट्स की साइड से जो करंट था वो रिवर्स हो गया। इसका मतलब यहाँ पर ये पार्ट तो करंट का यहाँ से रिवर्स हो गया। ठीक है, अब यहाँ से जो करंट चार्जेस फ्लो कर रहे हैं फ्रॉम राइट हैंड साइड 3 वोल्ट्स की साइड से, ठीक है, अब वो भी जब फ्लो करेंगे तो दूसरे एंड से जो रेजिस्टेंस मिलेगी वो मतलब ऑपोजिट है। 12 वोल्ट के चार्जेस एक एंड से आ रहे हैं, 3 वोल्ट की तरफ से चार्जेस एक एंड से आ रहे हैं। और डेफिनेटली 12 वोल्ट्स जो है वो हाई पोटेंशियल पे है एज कम्पेयर टू 3 वोल्ट्स। तो जब 12 वोल्ट्स को वो रिसीव ही नहीं कर रहा, उसने उसको रिवर्स बाइस करवा दिया यहाँ पर, और 3 वोल्ट की तरफ से अगर चार्जेस मूव करते भी हैं तो वो 12 वोल्ट को ओवरकम नहीं कर पाएंगे, क्योंकि 12 वोल्ट हाई पोटेंशियल पे, 3 वोल्ट लो पोटेंशियल पे है। ठीक है, और उसने 12 वोल्ट को रिवर्स बाइस कर दिया। तो जो करंट होगा फ्रॉम 2.1 ओम्स रेजिस्टर के थ्रू वो 0 एम्पियर होगा। ठीक है, क्योंकि यहाँ से कनेक्शन कंप्लीट नहीं हो पाएगा, क्योंकि वो 12 वोल्ट की तरफ से आने वाले करंट को रिवर्स बाइस कर रहे हैं। तो इसका मतलब है वहां पे इनफाइनाइट रेजिस्टेंस हो गई। ठीक है, जो हमने डायोड में किया था कि अगर वो फॉरवर्ड बाइस होता है तो नॉर्मल हम सिचुएशन को कंटिन्यू करते हैं, और अगर रिवर्स बाइस हो तो इनफाइनाइट रेजिस्टेंस वहां पर होती है, क्योंकि वो एक तरह से सर्किट को इनकम्प्लीट कर देता है। सेम प्रोसेस यहाँ पर होगा। तो जो करंट होगा थ्रू 2.1 ओम रेजिस्टर, 0 एम्पियर। ठीक है, क्योंकि करंट का पाथ वहां से क्लियरली बन नहीं रहा फॉर सेकेंड रेजिस्टर। और पार्ट 4, डिटरमाइन द रीडिंग ऑन द एम मीटर। एम मीटर देखते हैं कहाँ पे कनेक्टेड है। तो एम मीटर कनेक्टेड है लेफ्ट हैंड साइड पर, और यहाँ से आपने जो है वो करंट की वैल्यू को मेजर करना है कि फाइनल वैल्यू आपको कितनी मिलती है। तो एम मीटर में करंट की वैल्यू आपने फाइंड आउट करनी है, वो कितनी होगी, क्योंकि अब 2.1 एम्पियर आपको यहाँ से मिल रहा है, जो कि इस फर्स्ट रेजिस्टर से पास हो रहा था। ठीक है, अगेन सेम कॉन्सेप्ट, क्योंकि ये तो 0 एम्पियर दे रहा है, तो ये तो एक तरह से सर्किट कंप्लीट ही नहीं कर पा रहा अपना। तो जो ऊपर वाला रेजिस्टर है वो तो कनेक्टेड है स्टिल सर्किट में। सो फ्रॉम लेफ्ट हैंड साइड अगेन 12 वोल्ट, फ्रॉम राइट हैंड साइड 3, डिफरेंस 9 मिलेगा, रेजिस्टेंस 4.2 है। तो सेम करंट आपके पास फ्लो हो जाएगा एम मीटर के थ्रू भी, 2.1 एम्पियर। तो ये भी इक्वल होगा 2.1 एम्पियर। फाइनल कैलकुलेट द इलेक्ट्रिकल पावर ट्रांसफर in the 4.2 ohm resistor. So power is equals to potential difference into electric current. Potential difference is equals to 9. Electric current 2.1, 19 watts। ठीक है, तो ये पार्ट भी इजीली कंप्लीट हो जाएगा। नेक्स्ट। So again, figure 6.1 shows the circuit diagram for a flashlight, that is torch. EMF of the battery is 4.5 volt. The circuit contains 60 ohm fixed resistor. Current in the LED is, okay, so
Sir, I have a question.
hmm,
Can you like go back to the previous one? Yeah, can you explain why that current is zero?
basically when current starts to flow from this side, from 3 volt side, so it transfers to 2.1 ohm, right? And for this 3 volt potential difference, this diode is forward biased, right? But when the charges from the 12 volt side starts to flow, so that is reverse biased. So due to reverse bias, we already studied that there is a concept of infinite resistance. So no current flows through from left hand side. Current is only moving from right hand side. And potential wise, you can see that this 12 volt is higher in potential as compared to the 3 volts, right? और अगर आप इसको दोनों के पोटेंशियल को कंपेयर भी करते हो तो 3 वोल्ट इज वेरी मच लेस एज कंपेयर टू 12 वोल्ट। ठीक है, तो वो उन चार्जेस को ओवरकम भी नहीं कर पाएगा दूसरे एंड से, तो इसलिए यहाँ पर जो करंट है वो फ्लो ही नहीं हो पाएगा कंप्लीट, क्योंकि करंट और चार्जेस तब फ्लो करेंगे जब उसका एक सर्किट कंप्लीट होगा। ठीक है, तो वो यहाँ पर आकर ही सब स्टक हो जाएगा। So that's why the current from this 2.1 ohm resistance is equals to 0, right? क्योंकि बाकियों में क्या हुआ, 12 - 3, ठीक है, रिजल्टेंट निकल गया। लेकिन यहाँ पर आप रिजल्टेंट भी नहीं फाइंड आउट कर सकते क्योंकि 12 को तो आपने ऑपोजिट कर दिया आपने। ठीक है।
All right, sir, got it.
We only practiced 2 questions, and this is the third one. Okay, so in this question, it is related to the flashlight torch. EMF is given 4.5 volts, and the circuit contains a 60 ohm fixed resistor. Current in the LED diode is, light emitting diode is 0.02 ampere. Calculate the potential difference across the LED. So what will be the potential difference across the LED? 4.5 is the EMF.
Is
Okay,
it 3.3?
3.3. Okay. Current is given, resistance
I
is given.
also believe it's 3.3.
Yes. From Ohm's law, V is equals to resistance is equals to 60. One 1.2. And when we subtract it from EMF, 3.3. Because EMF is 4.5 and resistor is connected, LED is also connected. So first we find out the voltage of the resistance. This is the voltage of resistance actually. And then we subtract it from the EMF. So we will get the potential difference of LED, 3.3, right? And explain why the LED does not light up if the battery is reversed. This is the diagram. If we reverse the battery, so negative side will be on left hand side and positive will be on this side if we reverse the battery. So basically, this is also light emitting diode. Again, we have diode. And what is the function of diode? That it only allows forward bias, not reverse bias. So again, the problem is current starts to flow from the opposite direction. So that will be reverse bias. So due to reverse biasing, current will not flow through the LED. So this is the problem if we reverse the battery. So if we reverse the battery, reverse biased the diode. And the chemical energy stored in the battery is 1050 joules. So this is the energy stored in the battery and show that the flashlight operates for approximately 3 hours. Okay, so the chemical energy stored, this is the amount of energy given and show that the flashlight operates for approximately 3 hours. So we have to show that time is equals to exactly 3 hours. So the basic formula for electrical energy is V I T. So energy is given. Electric current is not given. So electric current is equals to
0.02.
yes, current is given, sorry, 0.02. So electrical energy is 1050. Potential difference is EMF is 4.5. 0.02. So time is equals to 0.02. So it will be equals to 1050 divided by 4.5 into 0.02. or it will be round off. Okay, first we will write original value, and round off we can say that. So this time is in seconds and we have to convert into hours. So in 1 hour there are total 3600 seconds. So divided by 3600 converts into 3.2 hours. Approximate equals to round off 3 hours, right? Because all other quantities are given in SI, so that's why the time also we calculate first is in the seconds. Then we have to convert that time into the hours. And the final part is, so in final part, we have to calculate the total charge that flows through the LED in 3600 seconds. I is equals to Q over T, or Q is equals to I into T. So 72 coulombs. Okay, it is also related to basic electric current. A cylinder is made up of modeling clay. The modeling clay is an electrical conductor. The cylinder is connected into a circuit. 8.2 shows that circuit also includes a battery of EMF 9 volt and resistor P. So this is the value of EMF, and the cylinder of modeling clay resistance of P is 4 ohms. Current in P is 1.5. Calculate the magnitude X of the charge that flows through P in 600 seconds. So this is also like the same. We have to find out the magnitude X. Again, Q is equals to I into T. Electric current is 1.5. Time is 600 seconds. 900 coulombs. Next part, the resistance of the cylinder of modeling clay. So for resistance, we use Ohm's law. V is equals to IR. R is equals to V over I. EMF is 9 divided by 1.5. That is equals to 6. Now cylinder is removed from the circuit and replaced with a new cylinder made up of the same material, and the new cylinder is twice the length and half of the cross-sectional area of the first cylinder. Now calculate the time that is now takes for a charge of magnitude x to flow through resistor P. So basically now we have new modeling, a cylinder made up of modeling clay, but length is double, but cross-sectional area is half. So these are the condition. So we know that according to the formula, R is equals to, so length increases 2 times, area decreases by 2 times, or it will be reduced to the half of the original value. So if we consider it is made up of same material means this factor is constant. So just ignore this factor, and length is 2 times of the original one, area is less than 2. So if we just remove these components, resistance will be equals to, it will be 4 times of the old resistance. So new resistance is like 4 times greater than the old resistance. So it means that the final resistance also increases by 4 times. And also we have to calculate the time for the same charge. We calculated the number of charge 900 coulombs. And we also need to calculate the time for the same number of charges with this new modeling clay. So now resistance is 6, that is the old one, and new resistance is 4 multiplied by 6 ohms, 24 ohms. So now we have to use 24 ohm resistance. Okay, again we have to use the formula for the Ohm's law to find out the new value of electric current. Same EMF 9, but resistance increase this time. So that is equals to 9 divided by 24. So this is the new value of electric current, 0.37 or round off 0.4 amperes. Q is equals to IT, or T is equals to Q over I. So Q is equals to the same value 900 divided by new value of electric current. So new value is equals to 900 divided by 0.4, 2250. So now this is the time required for the charges to flow throughout the new cylinder, which is connected as compared to the previous one. Okay, question number 7 is related to the electrostatic part. So a plastic rod is uncharged. When rod is rubbed with a woolen cloth, the rod becomes negatively charged. Explain in terms of particles why the rod becomes negatively charged. So this part is also simple. So rod is negatively charged and woolen cloth is positive. So definitely the electrons moves from the woolen cloth to the plastic rod. So electrons by the woolen cloth is gained by plastic rod and rod becomes negatively charged. Same in option B, it shows a negatively charged metal sphere S. It is negatively charged. Negative charge is distributed overall on the sphere. There is an electric field around S. What is meant by an electric field? So now we have to define what is meant by electric field. So that is also very simple. It is a region in a space where another charge experiences a force. On figure 7.1, draw the pattern of the electric field surround surrounding sphere S and indicates its direction. So basically for -1, we know field lines are radially inward. For S, and in figure 7.2, it shows a small negative charge Z placed near to sphere S, and charge Z experiences a force due to electric field surrounding S. On figure 7.2, draw an arrow to show the direction of this force on Z. So we have another negative charge. So if you remember, when we draw the field lines for two same charges, so definitely they will repel each other. So it will be like repelling each other. Okay, this is negative. For negative, we know it is inward. So for Z, we know Z is negatively charged, so field lines are inward. For positive, we draw radially outward. So we have to draw an arrow to show the direction of this force on the Z. So this is the field for the negative one, and to show the direction of the force. So force will be repulsion. So that will be away from the sphere. So this is the direction of the force, because both will repel each other, both consist of same charge. So field line is not important. Direction of force is important. You can also mark direction of force from this point or from this point. It's up to you. Okay, we skip this part. 7, it is related to the transformer. It is related to electromagnetic induction. So we will discuss this question with electromagnetic induction part. We consider question number 6 first because it is related to current electricity. Today we only solve questions related to electricity, electrical field, magnetic field. Next time we will practice questions from electromagnetic induction and electromagnetism.
So is it 9.8?
9. Okay, for current. Right.
Yeah, 9.8.
Okay. So heater uses a resistance of wire resistance 26, power dissipated 25, calculated the value of current. So this is now simple. Okay, voltage is not given. Yes, potential difference is not given. So we use different formula, I square R. So power is equals to taking under root on both sides. 9.8 amperes. Then we have resistance wire of the heater that has length of 1.2 meter and a cross-sectional area of 7.9 exponent minus 7 meter square. A new heater is designed using a wire of same material with length 1.8 meter and cross-sectional area, this one. Now we have to find out the resistance of the new wire. So this is length of the first wire. This is the cross-sectional area for the first wire. Then we have a new heater, same material. Resistivity is same. Length, cross-sectional area is different. We have to find out resistance. R is equals to rho L over A. And if we keep resistivity constant factor as a subject, so it will be equals to RA over L. So resistivity of first material is equals to the second one, R1 A1 over L1 is equals to R2 A2 over L2. So R1 is 26 ohms. Mhm. 26 cross-sectional area of A1, length 1.8 L2 divided by cross-sectional area of second wire 5.8 exponent minus 7 into length 1 1.2. So these are the quantities that we have to solve. So it will be equals to 26 into 7.9 exponent minus 7 into 1.8 divided by 5.8 exponent minus 7 into 1.2 bracket 53.12. The new resistance is 53 ohms. Because we know that resistivity is constant, so we make that quantity as a subject and find out the unknown quantity. Now, a 2500 watt heater is used in a country where electricity cost $0.30 per kilowatt hour. Calculate the cost of using the heater continuously for 2 days. 2 days means 48 hours is the time. And the cost per kilowatt hour is 0.30. So 25 divided by 1000 to convert this value into kilowatt. And then it will be equals to 2.5 kilowatt hour multiply by 2 days. It means 48 hours multiply by $0.30 is the cost. So after multiplication, we will get $36 as the cost, right?
How is it 36?
2.5 multiply by 48 multiply by 0.30.
Oh,
So this is part C. Question number 8 is also simple. Magnetic field, field lines. Same concept, cells are reversed. So this is, we skip this part. You may practice it by yourself. Okay. Question 7. It shows again a circuit that contains a battery and a switch, voltmeter, and 340 ohms resistor R1, R2, and R3 as shown in the diagram. The switch is open and resistors R1 and R2 from a potential divider. So R1, R2 is a part of potential divider. So describe what is meant by potential divider. So by name, you can identify to divide potential difference among the two resistors or two components connected in series, because in series combination, voltage or potential difference splits according to the value of their resistance. The potential divider splits the EMF or you can write voltage of a source between the components. Connected in series in the circuit. So basically, the reading on the voltmeter is 7.5 volt. Calculate the EMF of the battery. So voltmeter is connected over here. Yes. So voltmeter shows a reading of 7.5 volt, and we know that each resistor consists of a value 40 ohms, 40 ohms, 40 ohms. But this switch is open, so it means R3 is not connected in our circuit. R3 is still not connected in the circuit. So basically we know that there are two resistors and they have same value. So definitely potential difference also divides equally between them. So if 7.5 volts is the output for the first resistor, so definitely 7.5 is also the output of the second resistor. 7.5 plus 7.5, it will be equals to 15. So this is the value of the EMF. Now switch is closed. Calculate the resistance of the complete circuit. So now we have three resistors connected and this circuit is completed now. So basically R3 and R2, these two resistors are now connected in parallel combination. And then when we combine them, so these two will be connected with in series with R1. So first of all, we have to connect R2 and R3 in parallel. They are connected in parallel combination. So 1 over like this. Because we have 1 over 40 plus 1 over 40, 2 over 40, it means after cross multiplication, R23 is equals to 20 ohms, right? And finally, it is connected in series with the 40 ohm resistor, that is R1. So we have R2, 3 and R1 in series. So that will be equals to 60 ohms. And now we have to also find out the reading on the ammeter when the switch is closed. So now with this circuit, we have to find out the reading on the voltmeter also. So basically we have two resistor in parallel, right? And one resistor R1 is in series with the combination of these two because these two are in parallel and it is connected with R1 in series. And we know in parallel combination, potential difference remains the same. So we have to find out the reading in the voltmeter now. That what will be the reading in the voltmeter. Because when we join two resistance, so initially we have 40 ohm resistance, right? So we have equally divided volt potential difference, that is 7.5. But when we combine them in parallel, so in parallel combination, resistance decreases. So resistance decreased to half. From 40 ohms, combined resistance is decreased to half. So it means that the value of the voltage also decreases according to it. So basically, actually what happens, initially we have resistance, sorry, for R2, we have resistance 40 and R3 is connected in parallel with it, R2, that is also 40, right? So basically 40 plus 40, it will be equals to 80, right? But when we join them in parallel combination, so in parallel combination, we are getting 20 only. So basically, from the total 80 ohms, now we are only getting 20, right? So 20 means we are only getting 25% of the total resistance. Like R1 over R2 is equals to V1 over V2. So initially we have 15 volts EMF. Or you can simply relate with this concept that we are getting only 20 out of 80 ohms. So 20 divided by 80 means 0.25. So when we combine two resistors in parallel combination, so your total resistance is now only 0.25 times the original resistance. And according to that, if your total previous voltage is 7.5, so according to that scenario, the voltage throughout this connection is decreased and voltage for this connection increases because this is now in series combination and it will get More voltage because R2 and R3 are in parallel combination. So it will be equals to the final reading of the voltmeter coming out from the first voltmeter connected with R1. Question number is 11, again related to the electromagnetism. So we just skip this part. 9 is also related to electromagnetism. This is related to earthing. Okay, question number 8, again it is related to the potential divider. So figure 8.1 shows an electrical circuit. The light intensity at the circuit increases from dark to bright. So this time we have LDR and resistor connected in the potential divider. So state any effect on the resistance of the component Y. So basically name is not mentioned in the question, so it will be easy to identify. So you have to identify by this diagram given in the question, that is component Y. So component Y is actually LDR, light dependent resistor, and it also works in inverse relation. So when the light intensity at the circuit increases from dark to bright, so resistance decreases. And if it converts from bright to dark, so resistance increases. Next we have state and explain any effect on the reading of the voltmeter. So basically when resistance decreases, so definitely potential difference decreases. So the reading in the voltmeter also decreases. So resistance through LDR, potential difference across it also decreased. It means that reading in voltmeter decreases. In part B, the circuit shown in figure 8.2 switched on for 2 minutes. So the current in the 4 ohm resistor is 3 ampere and the magnitude of the charge on the electron is 1.6 exponent minus 19. Calculate the number of electrons that pass through the resistor each second. So we have to find out the number of electrons. So electric current is given, resistance is given, elementary charge of electron is given, number of electrons we have to find out, and time is 2 minutes, 120 seconds. So first of all, we have to find out the number of charges. Q is equals to IT, I into T, 120 seconds. So 360 coulombs is the charge. And now we have to find out the number of electrons. This is the total value of the charge divided by the value of a single charge, 1.6 exponent minus 19. It will be equals to, so these are the total number of charges or the number of electrons that are passing through resistor each second. Calculate the power dissipated by the resistor. So power dissipated, we have electric current, we have resistance. P is equals to I square R, and resistance is 4 ohms. 36. So this is question 8. Question 7 is very simple. It is related to the magnets. You only need to draw the magnetic field lines. So we consider question number 8. The unit of the two electrical quantities, EMF and potential difference, is the volt. State one other similarity. between EMF and potential difference. So we know that both quantities have same SI unit, so that is mentioned. Other than this, what is the basic similarity between EMF and potential difference?
They have this.
Yes, so we know that in the definition we have energy per unit time, work done per unit time. So work done energy both have the same idea. So both relates. The transfer of energy per unit time. Because we studied that in EMF, energy converts from non-electrical form to electrical form, and then in potential difference, it converts from electrical form to non-electrical form. So both actually relates to the transfer of energy per unit time. And also one difference. So EMF is like applied to the whole circuit and potential differences across the component. So EMF is applied to the whole circuit and potential difference is across the component connected. A battery consists of 4 cells, each of EMF 1.2 volt in series. Calculate the EMF of the battery. So we have 4 cells, all are connected in series. So very simple, 1.2 multiplied by 4, 4.8 volt is the EMF. Now the battery is connected in a circuit with four 12 ohm resistors. Figure 8.1 is the circuit diagram. Calculate the total resistance of this arrangement of resistors. Again, we have to find out total resistance of the resistors. So let's suppose if we name them R1, R2, R3, R4, all have same values 12 ohm. So R1, R2 are connected in series. So we can join them. R1 plus R2. So it will be equals to 12 plus 12, 24. Then R1 and R2, it is connected in parallel with R3. R3. One over 24 plus 1 over 12. So it will be equals to 3 over 24. It will be equals to 8. And final connection again with R4, it is connected in series. So total resistance is equals to 12 ohms. Sorry, 20 ohms. So this is the total resistance of the circuit. And then we have to find out the reading on the voltmeter that is connected with the R4. So the value of electric current passing from this whole circuit, it divides over here, then again it combines and it passes through R4 and resistance is 12 ohms. And total R1, R2, R3. So they combine and equals to 8 ohms. So basically, if we combine R1, R2, R3, so it becomes again a potential divider setup like this. This is one resistor combined from R1, R2, R3, which is 8 ohms. And then we have another resistor, R4, which is connected in series. And voltmeter is connected. So it is again a potential divider setup. So with the help of potential divider, we can solve this part also. It will be output voltage is equals to R4 on the top divided by combined resistance plus R4 multiplied by the input. R4 is 12, input EMF. 4.8 divided by 8 plus 12, again 20. So 12 multiplied by 4.8 divided by 20 is equals to 2.88, round of 2.9 volts. So in this way, we can solve this part of potential divider also. Mostly they ask questions related to the same topics in your syllabus. They just shuffle question or just arrange question like this. You have to find that hint from the question what actually they are asking about. When we are solving the previous part, part 2, the combination of the resistance. So in that part, you automatically gets idea that these three resistors are combined and it is now in series with R4. So that is actually the hint for your next part. Otherwise, you will get confused in the last part that how to find out that voltage. Maybe someone use the formula V is equals to IR, but that is not right because all resistors are connected with each other. Okay, skip question 7 for right now. Also this question 9, it is for electromagnetism. Now we have again the same idea. LDR is connected with the resistance. Same concept of potential divider. So try this question by yourself also. This is also easy. Okay, it is also related to magnetic field and electric current. Question number 10 related to electromagnetism. Okay, question number 9. Graphical representation for resistor, thermistor, and filament. It is given. Next, you can see we have filament, resistor, thermistor, all the graphical representation in a single graph. So the resistor, the thermistor, and the filament are connected in series. With a power supply, draw a circuit diagram for this combination. So all are connected in series. So let's suppose this is our resistor. This is our thermistor, lamp, circuit completes. So basically in this question, you need to know about all the circuit symbol of all the components. So actually, the marks are for those symbols. Then add a voltmeter to your circuit diagram in a correct position to measure the potential difference across the resistor. So we know that potentiometer or the voltmeter always connected in parallel. So it is connected in parallel with the resistance. Using the graph in figure 9.1, determine the potential difference across the terminals of the power supply when potential difference across the resistor is 6 volt. So from diagram, you have to find out potential difference across the terminals of the power supply when potential difference across the resistor is 6 volt. So resistor 6 volt. So the value of current at 6 volts for resistor is equals to 0.4 amperes current. And we know that current through all the components remains the same because all are connected in series. So we know that current remains same for all components. Connected in series combination. So basically from graphical representation, because in resistance we know there is a straight line, but it will not remain same for each component. So what we have to do, we have to draw a horizontal line to find out the value of the potential difference at the value of electric current. So this horizontal line shows that at this point, we have the value of electric current, same 0.4. So this line is coming for a filament. This one is for thermistor. So now you can easily get all the values. 3 volts, 9 volts. So this 3 volts is for filament. And this 9 volts is for thermistor. So you don't need to calculate anything. All the values you have to trace from the graph. Filament 3, thermistor 9. And for resistor, we have 6 volts. So the total EMF is equals to sum of all potential difference, that is 18 volts. And the final point is describe a practical use of thermistor. Thermistor works like when temperature increases, resistance decreases. So we discuss we use thermistor in the automatic street lights, or we can also use
Clear.
fire alarm
Clear.
system.
Can we say security alarms?
Yes.
All right.
So you can describe any use of your choice for thermistor. So this is a different question from the others because you have to find out all the quantities from the graphical representation. It will also give you idea that in this way we can also solve questions. Not all the time we have to use Ohm's law to find out any unknown quantity. Okay, this question is also simple. Negative plate, positive charge plate is given, and you have to definitely draw field lines between the two plates. We know that it will always move from positive to negative, and from the edges it will be curved. So these are the 5 electric field lines. And then in part B, electric iron has a power of 2400 watt. The potential difference of the main supply is 220 volts. Calculate the electric current in the iron. So P is equals to VI V is 220, 11 amperes or 10.9. And finally calculate the electric charge which flows through the iron in 15 minutes. Nine nine double zero coulombs. And fuse ratings of 3, 5, 10, 13, and 30 amperes are available. So which of these fuse ratings is suitable for use in iron? We have 11 ampere value of electric current, so definitely we will use 13. So this is the answer for the last part of this question. So mostly electricity part questions are not difficult, only sometimes when you got potential divider idea or the circuit diagram. So that is slightly typical because some hints are given in the circuit diagram. So you have to check that one very critically. And inshallah, in our next class, we will start with some electromagnetism and electromagnetic induction question. And after that, we have to cover nuclear and space physics. And tomorrow we also have our regular class at 5, uh, normal group class. So we will discuss questions of space physics in that class also. Okay.